On today's show, underwater adventure.
Yeah, we've got two major missions on this expedition.
Plus, finding Canadian homes for rescued Mexicans.
It doesn't matter where the dog's from. If it needs help, then we want to be there to help.
And expert advice on trying something new.
Sort of develop some skills you may not have known you had, or explore different things.
Welcome to Go on ShawTV. My name is Dan Kahan. Today we're bringing you the show from the launch of Ocean Networks Canada's Expedition 2016.
Yeah, we've got two major missions on this expedition.
Ocean Networks Canada is a University of Victoria initiative. ONC manages the world's most advanced cable ocean observatories off the west coast of BC and in the Arctic.
This technology is what we use for the Trans-Pacific and Transatlantic cables, so the deep ocean telecommunication cables. And they carry about 96 to 97% of our internet traffic. People think the satellites carry a lot, but it's actually the Trans-Pacific Transatlantic cable.
Just a day before departing from Victoria's Ogden Point, ocean engineer Adrian Round gave us a quick explanation of their latest expedition.
You can see that we're slowly ingesting the cables, which are in these containers on each side, bringing them into the cable ship tanks, and then the jointers on board will join the fiber optics together, join the armoring together.
Two ships will be working together on this expedition. The 142-meter Wave Venture will be carrying all the new cables, and the 64-meter Nautilus will make sure those cables are dropped right.
So we need another set of eyes down on the seafloor when the cable ship starts laying the cable. So for that reason, we're doing a two-ship operation. Cables deployed from the Wave Venture, but the Nautilus actually monitoring the touchdown, doing the plug-ins for us, and making sure that the cable lay as it's laid is correct. This is an Ocean Design International wet mate connector. It's a hybrid fiber optic connector. So inside that connector we have fiber optics and power. And it's wet mateable, so a robot will pick that up, and we'll see Hercules on the Nautilus. We'll grab that handle on the top and we'll actually plug it into a receptacle in salt water 3 kilometers under the ocean.
Nautilus is equipped with the latest in ocean technology, including 2 robotic vehicles, Argus and Hercules.
What happens is Argus moves up and down and is anchored to the ship, and then Hercules flies on a loose tether from Argus. So typically we have Hercules 20 or 30 meters below, an Argus above, and Argus moves up and down with the ship, and none of that motion gets translated to Hercules. Okay, so this is Hercules, which is the other component of the ROV system, and this is really the vehicle that does most of the work. You'll see these manipulator arms, which replicate pretty well all of the motions that you can do with your arm. They've got various elbow and shoulder joints, wrists that rotate. You'll see a huge amount of cameras and lights. It's very important that the ROV pilots understand what's happening around them. And as I said before, you only have limited field of view, and it's really dark down there. One of the jobs that we're going to do is we're putting early earthquake warning sensors down. And these are sensors that detect the first waves of an earthquake. Provided that the earthquake happens where the sensors are, you can then get a warning back ashore that in 30 to 60 seconds the shaking is going to start. And that allows you to do things like slow down a SkyTrain, bring all the elevators down to a ground floor, put a data system in a recovery mode, lift all the fire hall doors so that if the quake does hit, we don't have the doors jammed and can't get the fire engines out.
More from the Ocean Networks expedition launch in a few minutes, but first, a story about a woman who's devoted her life to providing opportunities for people with disabilities. Here's Daphne Good with the story.